Good morning, and here we are again for another week of maths. So yesterday you had a go at another arithmetic test. Today we are going to carry on with our topic of area and perimeter. This is going to be kind of the last lesson on this really before we move on to volume tomorrow. So today we are going to be able to use perimeter to solve reasoning problems. So you've done all the work on area and perimeter previously. And now we're going to use it to solve reasoning problems. So we need our reasoning brains switched on. We need to make sure that we are problem solving, that we are visualizing the problem, and we are collecting all the information that we need. Okay, right. Quick little rewind for us then. What is perimeter? Well, hopefully you have remembered that perimeter is the length of the outside of a 2D shape. What's perimeter? It's the length of the outside of a 2D shape. And if you haven't got that written down, write that down now. Okay, it is crucial that we have these STEM sentences written down so that we can see them, so that we make sure we remember them. Because sometimes when we see a problem, our brains go blank and we forget all about what perimeter or what area is, and then we get them confused. So we need to know that perimeter is the length of the outside of the 2D shape. Okay. Little fluency first for us then. Can you work out the perimeter of these two shapes? Pause the video and have a go. Okay then, so hopefully you have had a quick go at this and hopefully it wasn't too difficult. So we'll do this one first of all. So this tells me, the scale tells me here that one line is 1 centimetre. So I'm going to start from here. In fact, I'm going to change colour so you can see what I'm doing. So I know this has got a perimeter of 1 centimetre. Should we make it a bit bigger so we can see a bit better? There we go. 1 centimetre. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this has got a perimeter of 14 centimetres. Not centimetres squared, that's area. And centimetres squared is when we've got 2 dimensions. Here we've only got 1, so it just stays as centimetres. This one over here then, oh, this one's only given me 1 measurement. Can we still work this out? Yes, because hopefully you can tell me that that is a square. So all the sides are the same. So if this one's 5 centimetres, this one here is also 5 centimetres. So we've gone 5, 10, 15, 20. The perimeter would be 20 centimetres. So you could do 5 add 5 add 5 add 5, or 5 times 4. Same way, either way, you get the answer of 20 centimetres. Right, hopefully you got those right. Hopefully you are now confident with what perimeter is. Let's move on to this. So if you haven't already, if we write fluency first into your blue book, if you've got it, and if you haven't, just have a go with a jotter or on scrap paper. Okay, I want you to work out for me, what is the perimeter of this shape here? Pause the video and have a go. Okay then, so with this one then, hopefully you could see, where's my drawing? Here it is. Hopefully you could see that you've got a side of 1, 2, 3, 4, 5, 6 centimetres. And for the purpose of this, I'm gonna label it so you can see it. Then it had a length of 2 centimetres. This bit, also 2 centimetres. This bit, also 2 centimetres, because each square is a centimetre. Sorry, I should have told you that really. This side here, 2 centimetres. This side here, 2 centimetres. This side here, 2 centimetres. And then this top length is 1, 2, 3, 4, 5, 6. Also 6 centimetres. So to work out the perimeter of this then, I would do 6 centimetres out of 6 centimetres, which is 12, 14, 16, 18, 20, 22, 24. Did I do that right? I'm going to try that again. 6, 12, 14, 16, 18, 20, 22, 24. 24 centimetres squared. Oh, no, not squared. Goodness me, it's thrown me off now. Right, 24 centimetres. Okay, the perimeter is 24 centimetres. Okay, then. What about, we're going to have a look at this diagram. What about if we didn't have squares there? And all we had was certain measurements. So I'm going to get rid of this measurement here, this measurement here. I'm going to get rid of all these measurements just for the time being. Okay. If I've got rid of these measurements, and let's, for the time being, pretend that there is no grid. Okay, let's get rid of the grid. See if I actually can get rid of the grid. Not sure how to get rid of the grid, so we'll leave the grid there, but just pretend that it's not, okay? So this time round, we've got a length that is 6 centimetres here. Right. Could we work out the length of these 3 here? Come on, why are we not drawing them? This one, and this one. So we've not got the squares, not got the grid. If we know that this side here is 6 centimetres, can we work out what these 3 here must add up to? What must these 3 lengths add up to? Well, they must add up to 6, because you could move it. There's one, look. There's the other one. And there's the other one. So these 3 lengths must be the same as that top length, because they still go from here to here. So we know that this add this is 6 centimetres. If I then told you that they were then equal, we would do 6 divided by 3, which would tell us that each one was 2. From the grid, we know is correct. Okay then, this time, what about if we knew this length here, and I wanted you to tell me, what do these 3 lengths add up to? Well, these 3 lengths here must add up to 6 centimetres, because look, that's that section, and that's that section. So this, again, goes from the top to the bottom. It's just like you've cut that line up and you've just moved it. So they must equal 6 centimetres. If each one is then equal, 6 divided by 3 would then be 2. Okay then, let's clear all of that. And let's change our numbers. So this time I am going to tell you, let's do the other way around this time I'm going to tell you that this length here is 5 centimetres. I'm going to tell you that this one here is 5 centimetres. And I'm going to tell you that this one here is 5 centimetres. Can you now tell me what is the length of this length up here? So this time, don't worry about the grid. The grid's not right this time. Ignore the grid. Can you work this out using your reasoning, problem-solving skills? Well, hopefully you've told me that this is 15 centimetres, because this length is 5, this length is 5, and this length is 5. So the whole of this length must be 15 centimetres. Let's try one more then. So this time I'm going to tell you that this is 4 centimetres. This one is 4 centimetres. And this one is 4 centimetres. Obviously, they could be different measurements. It's just the shape I've drawn, they're all the same. So I want to keep it nice and equal. Right, what's this length here then? Well, we've got 4, 4, and 4, 4, 8, 12. So this then is 12 centimetres. Okay, well done. If we've got that bit, let's have a go at another one. Right, we've now got a different shape. So, can you work out which lengths on this shape could you add together to find out lengths on other ones? So, this time I am going to tell you that this length, we'll go for this one, this length all the way along here is 10 centimetres. Can you see, can you visualise which 2 other lengths would add together to be the same as this length here? Look at the way the lines are going. Look at the direction of the lines. Well, it would be this one and this one. Because look, if I moved them together, not that one. I want the line. Come here, pink line. There it is. So if we moved it together, look, that is then the whole of that length. Okay, let's put it back up here. Pretend I didn't break the shape. If then I told you that this length was 7 centimetres, would that help you to work out the length of this one, this missing length? Well, if the whole thing's 10, this part's 7, this part must be 3 centimetres. One more then, and then we'll go on to the discover. If this length here was, 12 centimetres, and this one here was, this is not the most accurate drawing, so let's say 2 centimetres, what must this length be? Well, hopefully you can tell me if the whole is 12, a part is 2, and this part must also be 10, because 10 add 2 makes 12. So this is part of the lesson today, is looking for these missing lengths and trying to work out which other bits you can work out from the information that you've got, okay? And this is why this is a reasoning problem, because you need to kind of think outside the box a little bit. You need to look at the information that you've got, label anything that you can, and then gather more information, okay? You've got to keep looking for what can you work out from what you have got. So in your blue book, can you write discover and underline it nice and neatly with a ruler? So this is our discover problem today. So as you can see from the picture, we've got a diagram, we have got a field, and we have got a tennis court, and they're kind of joined together to make in a, well, I can tell it's a square because I know it's 150 metres to 150 metres in the square, and this square represents the park. So Danny and Lee, you can see there, were running around the park. Danny took route A, so route A starts here, and he's gone the purple lines, look, so Danny is the purple lines to the finish. Lee took route B, so Lee is starting here, and he's the blue lines, look. So my first question is, who ran the greater distance? So one of them ran further than the other one. So can you work out who ran the furthest? And then the second part of this question is, how much further did they run than the other person? Okay, this is tricky, but think about what we've just had a go at and see if you can work this out. If you want to have a go, I would have a go at just sketching it quickly into your book. If you've got a ruler, brilliant. If you haven't, just have a go at roughly drawing it in. Can you work out who's ran the greater distance? Danny should be pretty easy to work out how far he's run. Look at Lee's. Look at what those lengths that you don't know are equal to. Pause the video and have a go. Right then, hopefully you have paused the video and given this a bit of a go. Hopefully it wasn't too difficult. So Danny, first of all then. So Danny ran down this length, which was 150 metres, and then he ran this length, which was 150 metres. So Danny ran how far? 300 metres, because 15 add 15 is 30, so 150 add 150 is 300. Okay, so well done if you got Danny. Now we're going to do Lee. So Lee ran down this bit along 55 metres, down this bit, which we don't know, along this bit, which is 71 metres, and down this bit. Okay, so Lee's are slightly trickier, but we can work this out. So for Lee then, what do we know already? Well, for Lee, we know that he's ran 55 metres plus 71 metres. Okay, we know those lengths because they've been given to us. We've still got, we'll do this in red, we've got 1, 2, 3 parts of Lee's run that at the minute are unknown. Okay, we don't know how far they are yet. We're going to have to work something out. Right, let's go back to blue. Okay. So I'm going to work out the bit that I know. So to do this, we need to do 55 add 71. So 1 add 5 is 6. 7 tens add 5 tens is 12 tens. So far I know he's ran 126 metres. But that's not it, because I know he's got these red bits that he's run as well. Okay, this is where the fluency first came in. Look at these red lines, these vertical lines that Lee ran. What are they the same as? What are they equivalent as? Well, they're actually the same as this length here. They are the same as 150 metres, apart from that 150 metres down has just been chopped up and has been moved. Okay, so he has actually ran 150 metres, but he's ran a bit down, bit across, bit down, bit across, bit down. He has run 150 metres. That's what the red equals. So I'm now going to do 126. I'm going to add 150. So 6 add nothing would be 6. 5 tens add 2 tens would be 7 tens. 100 add 100 would be 200. Right then, who ran the furthest? Well, Danny ran the furthest. And how much further did he run? So you find the difference between 300 and 276. So you can do 300, take away 76, 276, sorry, which would be 24 meters. So well done if you got that right. Okay, that was not easy. That would be a strong 2-mark question. That, so really well done if you followed that. Okay then, let's have a look at B. So B says the running club want to hang bunting, lovely, love some bunting, around either the perimeter of the whole park, that's the whole square, or just around the perimeter of the field. Which option uses less bunting? Okay, this is not too tricky because actually we worked quite a lot of this out already. So pause the video and have a go. Okay then, so let's work out. I'm going to get rid of some of my my scribblings, but I want to keep some of it because some of it I think is going to come in handy. So this is why you've hopefully got this written down. So hopefully it will be, your book will be nice and neat. So yours will be much easier to follow than what I've got on the board. Right, let's have a look then. So let's go back for purple and let's have a look at the perimeter of the whole field. So to do the whole field, I'm going to go down this side, which is 150 meters, along this side, which is 150 meters, this side, which is 150 meters because it's a square, and this side, which is 150 meters because it's a square. All the sides are the same. So the perimeter for the field is 150 times 4, or 150 add 150 add 150 add 150, which is 600 meters. And I know that because I know that 15 add 15 is 30, add 15 is 45, add 15 is 60. So I know that 15 times 4 is 60, so 150 times 4 is 600. Okay, I'm going to erase this bit. Perfect. Next one then. Now we need to work out the perimeter of the field, which I'll do in red. So we know that bit, 150. We know this bit, 150. So far we are at 300, oh goodness me, meters. Okay. We now need to add this bit, so this bit, and this bit, and this bit. We know, what was that bit? That bit was 150, wasn't it? Because it was side of one of the other, same as one of the other sides. So now I'm on 450 meters. I've still got a little bit more I want to do. Let's go for orange. So I've got this 71 meters, I've got this 55 meters, and I've also got this bit up here. Now you can work out what this missing bit is, which I'll show you in a moment. But what can you tell me about these orange sections? What can you tell me about these horizontal parts? Well, they are the same as 150 meters. Okay, it's the same as when we've done these vertical ones. It's exactly the same length, it's just been broken up, which means then we need to add another 150 to our 450, which would be 600 meters. So actually the answers are exactly the same. Okay, it would be exactly the same whichever way around you did it, because each one has done these two sides. And then this bit is the same as and then this bit is the same as the orange bit there. Okay, hopefully that all made sense. Right, I will show you how to prove your answer was correct as well. So you had got this bit, we knew this orange bit was 71 meters, we knew this red bit was 55 meters. What can you work out infer this section is up here? I'll give you a clue, you've already worked it out in the other problem. So in the other problem, how much further did they run? The answer was 24 meters. So what that was actually saying was this little section here is 24 meters. Because if you look, that's the only bit that is different. So this section here then is 24 meters. If you add 24, add 55, add 71 together, you would get 150, and that's where the missing length comes in. Brilliant. Right, really well done if you're following so far. I think that's the hardest bit. This bit gets a bit easier. So we are going to have a go at the think together. So into your maths book, right, think together. And here we go. Max has a square piece of material. The perimeter of the material is 40 centimeters. Okay. Every time you are doing any kind of reasoning problem like this, write down the information you know. So pause the video and write down what you know. Okay, so hopefully you can see in the corner then, the video has now turned to my camera so you can see what I am writing. I apologise for the horrible shadows. It's because the lights in here are spotlights, so they're right over my head. So apologies for that. So I've written think together. I'll probably write number 1, shouldn't I? I know that this is a square and I know the perimeter, P, is 40 centimetres. Okay, that's what I know so far. And I know that perimeter is the length of the outside of a 2D shape. Okay, and that's important that I keep saying that to myself. He cuts this material into 2 equal rectangular pieces. Okay, so I'm going to draw this just nice and quickly. I've got my ruler. If you haven't got a ruler, that's okay. Try and use something like the end of a book if you can, or a placemat. A placemat's quite a good one if you've got a placemat at home. Okay, what's the perimeter of each rectangle? So it's important I put it into 2 equal rectangular pieces. Tell you what, I'm going to draw the 1, 2, 3, 4. I'm going to draw the original rectangle as well, because I think that is probably going to help me. Okay, so here's my original rectangle, and I know that the perimeter is 40 centimetres. Right, what else do I know about it? Well, I know it's a square. Okay, so it's a square. The perimeter, sorry, cross out neatly with a ruler. The perimeter here is 40. So what much must each side be? It's a square, so each side is the same. So this must be 10, this must be 10, this must be 10, and this must be 10, because 10 times 4 is 40. So what can I label on these shapes over here then? Well, I can label that this side is 10, this side's then going to be 10, this side is also 10, and this side is also 10. Would this side be 10? This bit here, would these bits be 10? Well, hopefully you can see that the whole thing would be 10. Now it's been cut in half. 10 divided by 2 is 5. So that would be 5 centimetres. And that would be 5 centimetres. Right, let's add this up then. So I only need the perimeter of one of these. So 10 add 10 is 20. 5 add 5 is 10. Add them together and the perimeter would be 30 centimetres. Perfect. Next one. Okay, number 2 then. So I'm going to write number 2 onto my book. So first things first, gather the information. Okay, that's the really important bit here. You've got to gather the information that you know. So you have got a regular hexagon and a regular octagon have the same perimeter. Okay, what does it mean if they are regular? Well, if they are regular, it means that all the sides are the same. Okay, so a regular hexagon has got all the sides the same. Hexagon tells me it's got 6 sides, and an octagon, oct tells me there are 8 sides, and they've got the same perimeter. Okay, that's important to know that they've got the same perimeter as each other, and that every length is the same. So if the length of one side of the octagon is 9 centimetres, what's the length of one side of the hexagon? Okay, so let's work this out then. So I'm going to put octagon, one side equals 9 centimetres. Right, perimeter then of the octagon, each length is the same. So I've got 9, add 9, add 9, add 9, add 9 all the way around. Or I could just do 9 times 8 because I know that there are 8 sides. 9 times 8 is 72 centimetres. Okay then, let's look at the hexagon. So I know that the hexagon perimeter is the same as the octagon perimeter, so I know that it's 72 centimetres. Right, how can I work out just one side then? How can I work out one side? So if I know that all of these sides together equals 72 centimetres, and I've got 1, 2, 3, 4, 5, 6 sides, so I need to do 72 divided by 6, because each side is the same, and the answer would be 12 centimetres. So one length of the hexagon is 12 centimetres, one length of the octagon is 9 centimetres, but the perimeters are both 72 centimetres. Well done if you got these right. These are tricky. You're doing really, really well. Okay, I'm just going to give us one more problem to finish today. So stay with it. Keep going. So this is independent activity. So you can write independent activity into your book, pause the video and have a go at this one last question. Off we go. Right then, let's have a go 3 of these ones. Hopefully you found these okay. If you didn't, don't panic, okay? This is really tricky and you're doing really, really well. Okay, Max is competing in 2 running races. There's number 1. There's number 2. Using the information below, work out which race is longer. Right, okay then. So this is a perimeter question, even though it doesn't say perimeter in the question. But I can tell it's perimeter because I'm going around the outside of a 2D shape, and we know that that is what perimeter is. So here we have got them. This side is 100 meters. This side is 200 meters. This side is 300 meters. And this bit here is 110. So let's add up what we know straight away then. Okay, so let's add up what we know. So 300, 400, 500, 600, 710. So I'm just going to write down 710 meters. That is the section that we know. Okay, right. Let's see if we can work the rest of it out. So we also need to work out this length here. Which information that we know can help us work out this bit? Well, up here might help us. This length here might help us. So this length is 100 meters. The whole thing is 300. One part is 100, so this part must be 200. 200 meters. So we're now not on 710, we're now on 910 meters. Right, next bit then, let's go for blue, I think, and we'll make it a little bit thinner. So now we need to work out this unknown length here. Which lengths are we going to use this time? So I want all the ones that are going down vertically. So this one's 110, this one, my mouse then, this one here is 200. So the whole thing's 200. This part's 110, so this part must be 90 meters. So 910 add 90 would be 1,000 meters. So the perimeter for race number 1 is 1,000 meters. Apologies for my zeros. Right, next one then, race number 2. Okay, same thing again. I want to add up all the bits that I already know. So I know we've got, oh dear, that was very wonky even for me. Let's try that again. So we've got 300. Oh dear, that's even more wonky. 300, 450, 500, 630. We need to add this bit. So that would be 730. Do 730, add 80. If you're not sure, you can write it down. So you've got 730. I would add 70 to get to 800, but I want to add 80, so that would be 810. So I'm just going to write this down so I don't forget. Okay then. Ooh, this one's when it gets a little bit trickier, but we can work this out. So look at the information that you know. This is where I want to work out this little section here. Right, so I'm going to get rid of all my other drawings to make this one easier. So this is the section that I want to work out here. What do we already know? And here there's some information that we don't necessarily need. So we have got this section here. We know that the whole length is 200 meters. I know that this bit is 50, and I also know that this bit is 150, but actually, for the minute, this is not actually information that I need, okay? You need to find the bits that you do need, and this one was tricky because you had to kind of work out, actually, I didn't want anything to do with that section. So the whole thing is 200. So that tells me that this little 50 meters, can move it, that bit there, and this bit here, that adds together to make my 200 meters. So if this bit is 50 meters, what must this bit equal to make it 200? So the whole is 200, one part's 50, so this part must be 150. So I need to add 150 to the 810 I've already got. 110 add 5 tens would be 6 tens. 800s add 100 would be 900. Ooh. So the perimeter of race 2 would be 960 metres. Right, which race was longer then? Well, race 1 was longer because it was 1,000 metres. Really, really well done for today. I know that is not easy. That would be a really difficult reasoning question right at the end of the paper. So if you have followed that, amazing, really, really impressed. So take some photos of your work. If you've annotated the screen, brilliant. You can send that to me. You can take a picture of your maths book. You can just write me a little paragraph about how you found it and what you did. Any of those are fantastic. I want to see as much work as possible. So tomorrow we will be starting volume. We'll do 2 lessons on volume, and then Friday will be an end of unit topic and overview, and we will be quizzing you on everything you have learned. Big well done for today. That was not easy. I will see you soon. Bye.